Okay, make sure you understood the longshore drift and the rip currents. You can easily Google it. It's very well known. You've probably heard of it. Now let's look at the processes that go on at the coasts and how they determine the physiography of the coast. So there are two major types of shores, erosional shores and depositional shores. Okay, erosional shores are, for various reasons, have constantly energy being deposited at the coast and eroding the material. It could be because of the confluence of wind energy and the waves and the angle of the shores, etc., etc. And we'll see that the US, for example, has a erosional coastline on the west and a depositional coastline on the east, whereas something like India, it's very mixed because it has river deltas on both coasts. In general, has nicer beaches on the Arabian Sea side than on the Bay of Bengal side, but Bay of Bengal side has some massive river deltas, so it depends on the kinds of processes. Erosional shores have very typical features which look like well-developed cliffs. Every soft material has been eroded out and you are just left with cliffs, and there are tectonic uplifts that tend to occur, and US Pacific coast is one good example. As I said, depositional shores have more gradually subsiding shore and not cliffs, barrier islands, sand deposits, and so on. So there are a lot of features that we will see with images so that the concepts remain solid in your head, and as soon as you see an image of a coastline, you can probably guess whether that's a erosional feature or a depositional feature. Okay, so here are the erosional shores. Typically they have things like a headland. Remember, we said the energy of the waves gets refracted and focused on the headland. So headland erosion rates can be higher than the cove that's behind. And if the headland has different materials, then part of the headland material can be completely eroded out, and you end up with what is shown here as a sea arch. And if it is completely disconnected from the mainland by the erosion, it can become a sea stack. You get sea cliffs, you get caves and blowholes and uplifted marine terraces, which is related to a plate that is, for example, subducting. The Pacific plate is subducting under the North American plate, then it pushes up the plate, so you can have these uplifted marine terrace like feature. Of course, wave cut benches, which basically means constant deposition of wave energy has eroded the nice sandy part and has left just a rocky bench at the bottom. So these are the typical features. So sea arches, sea stacks. You can go to many beaches and find these in northern France. Of Biarritz, for example, you find tons of erosional features. Uplift is something that has been eroded by the marine processes before, and it's been tectonically uplifted, or sometimes sea level has been changed. Okay, so wave erosion obviously increases as more shore is exposed to the open ocean wave energy, and the tidal range can be smaller, and the bedrock is weaker, and that's why it's getting eroded easily by the wave energy, right? So those are the features of a erosional coastline. We will see in the next podcast a depositional shoreline, and then we will look at many images of real beaches so that you can identify whether it's a erosional coastline or a depositional coastline. Again, this is just the accident of geography and the processes that go with it. For example, a softer bedrock is not something is created by humans. It's a natural process, right? So coastlines have natural features.